Hello dear students, today we are going to continue with our first unit with the next topic, that is gram atomic mass. There are some other topics also like dimensional analysis, but since these things you already study in physics, so we are not going to discuss them again in chemistry. So let us see what is the meaning of gram atomic mass. This is a very simple concept. It says nothing, it just says that whatever thing or whatever mass of any atom that you write in daltons, change the unit to gram. As simple as that. So atomic mass of an element which is expressed in grams. This is gram atomic mass, that is atomic mass expressed in grams. Second is gram molecular mass. Molecular mass. Molecular mass means the sum of all the elemental atoms present in a molecule. Means we have to take, suppose a molecule of Cl2 is there. In Cl2 molecule we have two chlorine atoms. So the individual atomic masses of chlorine atoms, both of them we have to add to get the molecular mass. Suppose we have to calculate the molecular mass of glucose. The molecular mass of glucose, first of all, for that we should know the individual atomic masses of everything, that is of every atom, and then we should also know the formula of glucose. This can be provided in exam, but the masses you have to learn. Now we'll write here, instead of this C, what can we write? We can write 12, because 12 units is the mass of carbon, multiply by 6. Similarly 1 unit for hydrogen, multiply by 12. Similarly for oxygen we have 16 units, multiply by 6. On solving this we get 180 units, or we can say 180 daltons. This is our molecular mass of glucose. Next is gram molecular mass. Gram molecular mass is also again very simple. Instead of this unit, when you write gram, it becomes gram molecular mass. Suppose the molecular mass of oxygen is 32. Oxygen means O2. So for oxygen, if it is 32 units, why? Because oxygen molecule contains two oxygen atoms, so addition of both of their masses, that is 16 plus 16, gives 32, and the gram molecular mass will be 32 gram. Just instead of the 32 U, you will add 32 gram. Now there are some questions. Calculate the mass of 0.5 gram molecule of sugar. So we should know that what is the mass of sugar, that is the molecular mass of sugar or the gram molecular mass of sugar. So it is written over here already, this much. Okay, so this is 342 gram molecular mass. It means one molecule of sugar has how much gram molecular mass? 342 gram. We are asked in the question to calculate for 0.5 molecule. How much it will be? It will be 342 upon 1 multiplied by 0.5, means the half of this, it will be 171 gram. Second question, we have to calculate the gram molecule of sugar in 547.2 gram. We already see that, or we already know that 342 gram of sugar contains one molecule. So instead of this, if we have to write that, or not one molecule, 1 gram molecule. Similarly here also 1 gram molecule, because one molecule is very small, it is a gram molecule. So 342 gram of sugar contains 1 gram molecule of sugar. So if we have to see the gram molecules of sugar in 547.2, means how much gram molecules in 547.2 gram, that will be equal to 1 upon 342 into 547.2, that is 1.6 gram molecules, which means in 547.2 gram sugar you have 1.6 gram molecules of sugar. Next is formula mass. Formula mass is used for ionic compounds. Suppose you have an ionic compound. Ionic compound always contains cations and anions. Suppose you have NaCl. NaCl contains cation as Na plus and anion as Cl minus. This is an ionic compound. So the formula mass can be calculated as number of cations multiplied by atomic mass plus number of anions multiplied by atomic mass. So number of cations here is 1 multiplied by 23.5 because the atomic mass of sodium ion is this much, plus number of anion again 1 multiplied by 35.5 because that is only the atomic mass of chloride ion. This is the formula mass. The next important topic is mole concept, which is the main topic of this chapter. Before we start, let us see the basics, that what is the meaning of mole. Mole is any amount of substance that contains as many particles or entities as there are in exactly 12 gram of carbon-12 isotope. 12 gram means 0.012 kilograms. So they are saying that mole is that amount of substance in which the particles are equal to the number of particles in 12 gram C12 isotope. Means whatever are the number of particles in 12 gram of this carbon-12 isotope, the same number of particles will be there in 1 mole of any substance. Now we have to find out that what are the number of particles in 12 gram of C12 isotope. For that we should know that what is the mass of one carbon atom. It is 1.99 multiplied by 10 to the power minus 23 grams. 1 mole of carbon will contain 12 gram. Hence, number of atoms in 12 gram carbon will be how much? That is 12 gram per mole upon 1 atom mass, that is 1.9926 multiplied by 10 to the power minus 23 gram per atom. So you get how many atoms for 1 mole? You get 6.022 into 10 to the power 23 atoms per mole, which says that for 12 gram of carbon-12 isotope or for 1 mole of carbon-12 isotope, you have total 6.022 into 10 to the power 23 atoms. Hence, in 1 mole of any substance, it will contain 6.022 into 10 to the power 23 atoms. Now this number became constant. This number is known as Avogadro's number because it was discovered by Avogadro. It is represented as capital N and in the subscript capital A. Now we'll talk about the gram formula mass. Again the same thing. Instead of this unit, we have to write gram. Now we'll see the mole concept for gases, that what are the moles. So for gases we talk about the volume, right? So 1 mole of a gas means the 22.4 liter volume of that gas occupied. This 22.4 liter is constant. It is experimentally determined and hence you have to learn this numeric value. So 1 mole of a gas will always occupy 22.4 liter volume. This volume is known as molar volume. Now there is some formulas like number of moles equals to given mass upon molar mass. This is the basic thing that you know. Next, that the moles of gas, for gas we have this formula, that is volume of gas upon 22.4 liter, and 1 mole contains Avogadro number of particles. Let us come to the important questions which are given over here and we'll discuss all of them one by one. The first is that we have to calculate the number of moles in the following. The first is 7.85 gram of iron. We right now saw that number of moles formula is given mass, that we write by W, and molar mass is M. So for this the given mass is how much? 7.85. okay, and the gram molar mass given is 55.9 or gram atomic mass. Okay, you have to just solve this and you have to get your answer. So when we solve this, we'll be getting our answer as 0.14 moles. So 7.85 gram iron contains this much moles. Second is 4.68 milligram of silicon. Number of moles is always given mass upon molar mass. Now this is 4.68 milligram. So to convert it into gram, we write 10 to the power minus 3 upon the silicon, that is the atomic mass is given 28.1. We put this, so we will get our answer, and when we solve it we get 1.67 multiplied by 10 to the power minus 4 moles. Third, 65.6 microgram carbon. So number of moles is given mass upon molar mass. Given mass is 65.6 micro. When we saw that table, we saw micro can be converted by 10 to the power minus 6 upon 12, which is given here. On solving this, it is 5.47 multiplied by 10 to the power minus 6 moles. Now next, calculate the number of atoms in the following. The first given is 52 mole argon. Now we know that 1 mole of any substance contains 6.022 into 10 to the power 23 atoms or particles. So 52 moles will contain how much? 52 multiplied that Avogadro number. These atoms are present inside the 52 mole of argon. Second is 52 units, or sorry, 52 mass, that is 52 of helium. So first of all, we need to find out number of moles. Number of moles will be equal to given mass upon molar mass. Given mass is 52, molar mass is 4 for helium. Solving this, we have to find out first of all that what is the thing coming over here. So when we solve this, we'll get here 13. Now this 13 will not be multiplied by this Na. Do you know why? Because here we are given unit, not gram. Gram is a bigger unit which will contain these many atoms, Avogadro also. But since we are only taking unit, means these are the matter of just few, very few. Unit means like one atom is of few units only. So the 52 units will make up 13 atoms only. Let us see the third one, that is 52 gram of helium. Now this time we have to multiply this 13 with Na to find out the value, because this gram is bigger unit. In this way we can solve these questions. The last topic for today is to calculate the percentage composition. Now what is the meaning of percentage composition? Percentage composition is the number of parts by mass of that element or constituent present in the 100 parts of mass of the compound. Suppose you have a compound which contains of 100 parts. Now there is one element in the compound which is of 35, which makes 35 parts of the compound. So what is the percentage composition of that element? It is 35%. So you have to find out that how many parts of the total compound does that element occupy, and multiplying it by 100 will give the percentage composition. Now what is the step to calculate the percentage composition? First is calculate the molecular mass of the compound from its formula by adding the atomic masses of all the elements present. So you have to first of all find the molecular mass of the compound, then calculate the mass percentage of the element by using the expression mass of that element upon molar mass of the compound, which we calculated in the first step, multiply by 100. Let us see one question. Calculate the percentage composition of each element in water. Now how many elements are there in water? One is hydrogen, one is oxygen. First of all, we should find out what? We should find out the molecular mass of water. Molecular mass is how much? Calculate this. Atomic mass of hydrogen is 1 multiplied by 2 plus 16, that is 18 units. Now we have to find out the percentage composition. So we'll find out the percentage composition of hydrogen. So mass of that element means mass of hydrogen, that is 2 upon total mass is 18 multiplied by 100. So this is here, it will be equal to 11.18%. Second is percentage composition of oxygen, that is mass of that element which is oxygen. Here it is 16 upon total is 18 multiplied by 100, you will get 88.79. Or else you can directly solve from here, that 1 is already solved, so other can be easily carried out. In the case of 2, we can calculate easily that out of 100 how many parts are left for the other element. So this is all for today.